As I was charging up one of my lithium ferrite phosphate batteries, I happened to reach down and touch one of the terminals. I don't really recall why, but I touched it right here. Not where the screw is, but where the immovable part is. And I burned my finger, lightly. Besides yelling, ow, I thought, what the heck? This is only with a 10 amp charger. But it was generating enough heat that it actually burnt my finger. Thinking it through for a moment, I remembered that I had connected something earlier and left one terminal bolt, maybe just barely finger tight. So there was enough resistance between the bolt and the battery itself that even at a 10 amp charge, it caused heat there. Now, what's bad about heat? Heat means that there is resistance between two things. Maybe you felt wires before that were warm when current was flowing in them. That warmth is generated by resistance to current flow. A warm wire or battery terminal means that you're wasting current in generating heat rather than sending all the current available to whatever it is that's being powered or charged. I grabbed my multimeter and measured a 0.5 volt drop between the clamps and the battery terminal due to poor contact. So the charger thinks that the battery voltage is 0.5 volts higher than it actually is, which could result in your charging session ending before the battery is fully charged if you're using a smart charger. For a lithium ferrite phosphate battery, this is especially concerning because this impairs the smart charger's ability to accurately measure the battery voltage that rises towards the end of the charge cycle. I'm guessing that this could easily result in your battery only reaching maybe 70% or less of its capacity. Wow, if you've effectively turned your 100 amp hour battery into a 70 amp hour model. So even though I should know better, I got a remedial lesson in why I need to check my connections and make sure they are tight and I can feel no current being lost as heat. Anytime you feel heat anywhere, that means there's resistance. Another thing to notice too is on these clips you see where the wire is connected to the one side of the clamp, but it's not connected to the other side. That means that the current is basically only flowing through that side of the clamp plus whatever current gets through where these rivets are that hold the two pieces of the clamp together. And it's just riveted on either side. So not an excellent connection there. Depending on how poorly designed your clamp is, if it's providing clamping force, you may not have as much current going through here or anywhere in the worst case. That might happen if there's corrosion or dirt on the rivets. So just something to keep in mind. It wouldn't hurt to get out a voltmeter when you're charging your batteries and just double check that you're making good contact, clean contact, and that you don't find any heat anywhere around here, especially if you're charging at higher current levels like I was. I don't think 10 amps was that high, but it was high enough for me to notice and high enough for me to burn my finger.